Okay, students, we now start to solve the second page on the first term review. We have two questions, question number 4 and 5. For question 4, we have a rocket with mass 20,000 pounds and its speed is 70 feet per second and its acceleration 5 meters per square second for 12 seconds. Okay, we need all the units in SI units, in meters and in kilograms. So we have 4 parameters for given information, which is the mass, the velocity, the acceleration, and the time. The mass and the velocity are in pound, are in feet per second. We need to make them in SI units. Okay, we need to solve them. Look here. The value of mass, which is 20,000 pound, we need to use the conversion coefficient, which is the conversion between the kilogram and the pound, which is in the given sheet. We use the conversion coefficient, which is 1 is equal to 1 kilogram over 2.205 pound, which is equal to 2.205 pound over 1 kilogram. This is equal to 1. We need to multiply the mass, the given mass in pound, with one of these two values, which are and we need to cancel the pound unit from here. So we'll use this first one. Okay, so multiply 20,000 pound, multiply by 1 over 2.205 in pound. We can cancel the units, the final unit in kilogram. It will be 20,000 over 2.205, which is equal to 9,070.3 kilograms. This is the mass. The velocity, feet per second. We need to change feet to meters, and the second will stay the same. So 70 feet per second, we will multiply it by meters per feet, which is 1 meter is equal to 3.28 feet. This is exist here. We use this converging coefficients. We need to use this one to cancel the feet from here and the feet from the given value, and the second will stay the same. So the value will be 70 over 1 multiplied by 1 over 3.28 will be 70 over 3.28 meters per second. This value will give us the velocity 21.34 meters per second, and the acceleration and the time are stay the same. Okay, the requirement B, what is the displacement of the rocket while it's accelerating? Okay, if the rocket moves from this point to this point at t equal to 0 and x equal to 0, it accelerates for 12 seconds. Then its velocity stay constant. What is the displacement here? We have 3 equations of motions where are here in the given sheet. We will use the first one. X final is equal to x initial plus vt and t and plus half a squared t. Okay, this is the equation. X naught is 0. V naught, we have V naught. We convert it. It is not 70. It is 21 in meters. 21.34 multiplied by the given time plus half. The acceleration is 5, positive sign, and the time is 12. We need to square it for this term. So the final displacement from the initial point to final point for this period is 616.1 meters. Okay, this is for B. What we need to compute for C? What is the final velocity when the boosters are turned off after 12 seconds? As we said, the rocket accelerates for 12 seconds. What's the final velocity? We can use two equations. V final is equal to V initial plus A Vt. Also, V2 squared is equal to V1 squared plus 2AX. We find X, which is 616 point something. Okay. If we solve using the first equation, V2, which is V final, is equal to V initial, which is 21.31, not 70 feet per second. Okay. Plus 5, which is the acceleration, plus the time, which is 12, and the final velocity will be 81.34 meters per second. I can use the second equation. V2 squared is equal to V1 squared, which is 21.34 squared, plus 2 multiplied by the acceleration multiplied by the x. This way, this is equal to 616.19 meters per second squared meters per second squared, because the velocity is squared here. Okay, if we need to find the value, we need to take the square root for this value, which give us the same velocity. We will find the same velocity using the two equations. Okay, the part D. If the rocket continues traveling 2 minutes after boosters turned off, what is the total distance? Look, at time equal to 0, we have positive acceleration 5. At t equal 12 seconds, the acceleration stops, and we have here V1, V initial, and we have here V2, which is 81, and this is constant velocity to the third point. Third point, it is at t equal to 2 minutes plus the 12 seconds. Okay, we have two periods. Okay, we need to find, we already find the distance for the first period, which is 616.1 meters. Then we need to find the second displacement, which is x equal to v naught multiplied by t. The v naught here is 81.34 at this point. This is the velocity multiplied by the time. The time is 2 minutes for this period. The initial velocity is the final velocity for the first period, plus half a multiplied by square t plus x naught. X naught, it is the same distance what we solved here. This is x naught for this period. The acceleration is 0 because the engines are stopped. Okay, so the velocity, the total distance will be v multiplied by the time plus x naught, which is 661.1. The velocity is 81.34 multiplied by the time, which is 2 minutes. 2 minutes are the same because 1 minute is equal to 60 seconds. 2 minutes are 120 seconds. So the total displacement will be 10,377.03 meters. We can convert it to kilometers, which is more than, it is about 10 kilometers, 0.377. So this is the question number 4. Okay, we need to see now question number 5. A ball is thrown at an angle above horizontal. The ball takes 2 seconds to reach from the first point to the second point. It takes 2 seconds to fly to this upper point. This is the third point, the final point. Okay, A, what we need to find. A, if the ball is initially thrown in velocity 34, this is the initial velocity or the initial speed, 34 meters per second. What is the angle? Theta. Okay, can see that. We have the going up time to hit this point is 2 seconds. And we can find also that the falling down is 2 seconds. The flying down time will be 2 and 2, which is 4 seconds. Okay. The initial speed is 34 meters per second. We need to find this angle. Okay. In y direction, Vy at point 1 is equal to V naught sine theta. V naught is 34. We know also Vy at this point is equal to 0. We can use this equation. V2 is equal to V1 plus AT. V2 in y component, in y direction, is 0. V1 is V naught sine theta, as we said before here. The acceleration is g, which is negative 9.8 meter per square second, and the time is 2 seconds. Okay, so we use the equation now. 0 is equal to V naught sine theta, which is the vertical velocity at the initial point, minus 9.8 multiplied by 2 seconds. We can move this term to the left hand side, and 19.6 is equal to 34, which is the V naught multiplied by sine theta. We need to find theta. We can divide over 34. So sine theta is equal to 0.576. Theta is equal to sine inverse for this value. And we can find easily that theta is equal to 35.2 angles in degrees, not in radians. Be careful for that in your calculator. Okay, this is part A. What about part B? What is the displacement? No, not this one. What's the ball initial vertical velocity? We need the vertical velocity. We have, this is the point 1, which is this one, Vy1, and we have horizontal velocity, which is Vx1. This is theta. In this direction, we need to compute cosine theta. In this direction, we need to compute sine theta, because it is adjacent to theta. Here, this one, this side, we need to use it with it cosine theta. Okay. B. This is B. We have Vx is V naught cosine theta. Vy is V naught sine theta. We have theta 35.2. We compute it now. And the velocity, initial speed or initial velocity is 34 meters per second. We have this is projectile motion. We have point 1, point 2, point 3. Keep that in your mind. In the horizontal direction, V naught cosine theta. We find now Vx at point 1, which is equal to 27.8 meters per second. And Vy, which is V naught sine theta, is equal to 19.6 meters per second. So this is V vertical. We need to find the flight time for part C, which is twice the going up time, climbing down, or twice of falling down, which is the time is 2. 2 by 2 is 4 seconds. That is because we don't have any air resistance. Okay. For part D, we need to find the horizontal velocity, Vx at the first point. We compute it now here. It is 27.8 meters per second, which is constant along all of our track, because we don't have any acceleration, we don't have any air resistance to reduce this velocity or increase it. We don't have any acceleration in horizontal direction. So when we need to find the range, which is from x, from the first point to the third point, this is the range, all of the x displacement. We can use the equation x is equal to x naught plus v x at this point, and this is vx at, I need to compute x3, which is equal to x1 plus v at x1 multiplied by the t is the flying time all the time, plus half the acceleration in x direction multiplied by the flying time all the time squared. The acceleration is 0, and the x at this point we can take it 0, so we can find that the total displacement is the velocity in x direction, which is 27.8, multiplied by the flying time, which is 4. The total distance in x direction is 111.2 meters. And this is the second page in the review. See you in the third page. Thank you.